we are going to study a topic, specific heat capacity. Now, what are the factors on which the quantity of heat required to raise the temperature of a substance depends? So, quantity of heat required to raise the temperature of a substance depends on what all factors? That is the question. For example, if you consider an example, if you have taken m amount of water, okay, let m is the mass of water taken inside a container. If you want to increase the temperature by 20 degrees Celsius, okay, if the temperature has to be increased by 20 degrees Celsius, let the quantity of heat required be Q1. So, what is Q1? It is the quantity of heat required to raise the temperature of m mass of water by 20 degrees Celsius. If you take double the amount of mass, if 2m mass is taken, and again if you want to increase the temperature by 20 degrees Celsius, how much quantity of heat is required? Let it be Q2, and Q2 is always double that of Q1 because the mass doubles. So, quantity of heat required to raise the temperature also doubles. And if you take the same amount of mass, and if the quantity of heat required to raise the temperature of same amount of water by double the temperature, if you want to increase the temperature by 40 degrees Celsius. Clear? Now, what is the quantity of heat? Let it be Q3, and it is always equal to double the times of Q1 because here mass remains same, but the increase in temperature doubles. So, quantity of heat also doubles. So, this is an example to explain the amount of heat required to raise the temperature of a substance. So, instead of water, in all the three examples we have taken water. Instead of water, if you take oil, okay, any type of oil, and if you want to increase the temperature, same amount of oil, m mass of oil, and if you want to increase the temperature by 20 degrees Celsius, what is the quantity of heat required? Let it be Q4, and Q4 is always less than Q1. So, we know that oil heats up faster than that of water. Okay, so if same amount of oil is taken instead of water, and if you want to increase the temperature by same 20 degrees Celsius, comparatively less quantity of heat is required. So, what are the factors on which the quantity of heat required to raise the temperature depends? It depends on mass. If mass doubles, then what happens to quantity of heat required? It also doubles. And it depends on the change in temperature. If the change in temperature doubles, the quantity of heat required also doubles. Then it also depends on the nature of the material. Okay, as the nature of the material changes, the quantity of heat required also changes. So, from the given example, we can say that the quantity of heat required to raise the temperature of any substance depends on the mass of the substance, m. It depends on the change in temperature delta T. Okay, delta T represents small change in temperature, and it also depends on nature of substance. So, quantity of heat required to raise the temperature of any substance depends on the mass, change in temperature, and nature of the substance. So, we can write the quantity of heat is directly proportional to mass of the substance. It is directly proportional to change in temperature. Okay, combining these, we can write Q is proportional to mass into change in temperature. As mass doubles, we can see that the quantity of heat also doubles. If the change in temperature increases, quantity of heat required also changes. So, we can write Q equal to, proportionality can be converted, changed by a constant. Here the constant is S into m delta T. Okay, or we can rearrange it and say Q equal to m S delta T. Here S is a constant which is called specific heat capacity. So, quantity of heat required to raise the temperature, it depends on mass, specific capacity, and change in temperature, and specific capacity is a constant for a given material. Okay, and what is the unit of specific capacity? Unit of specific capacity is, we have S is equal to Q divided by m delta T, isn't it? Q divided by m delta T. What is the unit of quantity of heat? Joule. Joule divided by m, kilogram. Temperature, degrees Celsius, change in temperature, no? So, it can be degrees Celsius or Kelvin. So, SI unit of specific capacity is joule per kilogram degree Celsius or joule per kilogram Kelvin. Okay, children? Now, how will you define specific capacity? We have specific capacity S is equal to Q divided by M delta T. Clear? So, if M is equal to 1 unit or 1 kilogram and change in temperature is equal to 1 degree Celsius or 1 Kelvin, and if M equal to 1 kilogram and delta T equal to 1 degree Celsius or 1 Kelvin, how will you write specific capacity? S is equal to Q. So, it is the quantity of heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius or 1 Kelvin. So, definition is specific capacity of the substance is defined as the quantity of heat required to raise the temperature of unit mass of a substance by 1 degree Celsius or 1 Kelvin. Now, for gases, mass is expressed in moles. Okay, and hence the specific capacity is called molar specific heat capacity and it is represented by C. For gases, there are two types of molar specific capacity. First one is Cp, that is molar specific heat capacity at constant pressure, and Cv means molar specific heat capacity at constant volume. So, for gases, mass is expressed in mole and hence the specific capacity is called molar specific capacity. That is the only change. And there are two types: molar specific capacity at constant pressure, which is defined as the quantity of heat required to raise the temperature of 1 mole of a gas by 1 degree Celsius, keeping which one constant? Keeping pressure constant. Clear? How will you define Cv? It is the molar specific capacity at constant volume, and it is defined as the quantity of heat required to raise the temperature of 1 mole of a gas by 1 degree Celsius, keeping volume constant. So, if we kept volume constant, that specific capacity is called molar specific capacity. If pressure is kept constant, then that specific capacity is called molar specific capacity at constant pressure. Clear, children? You will learn more about molar specific capacities of gases under different conditions, that is constant pressure and constant volume, in the next chapter, that is thermodynamics, and in that chapter you will also study the relation between Cp and Cv. Water has highest specific capacity compared to other substances. Specific capacity of water is 4186 joule per kilogram Kelvin or 4186 joule per kilogram degree Celsius, and hence water is used as coolant in automobile radiators, nuclear reactors, etc., because water can absorb any amount of heat without much raise in temperature. Okay, and since water has highest specific capacity, water is used as heater in hot water baths. That means it can radiate any amount of heat without much decrease in temperature. Okay, so because of that reason, water is used as coolant in automobile radiators and also used as heater in hot water baths. Now we can study what is calorimetry. Calorimetry is a branch of physics which deals with the measurement of heat transferred from one body to another. What is this principle of calorimetry? We know that when two bodies at different temperatures are placed in contact, heat lost by the hot body is always equal to heat gained by the cold body. So, we know that when hot body is placed in contact with the cold body, after some time the cold body gets slightly heated up and the hot body loses the amount of heat. Okay, so when a hot body and cold body are placed in contact with each other, the principle of calorimetry states that heat lost by the hot body and heat gained by the cold body are always equal, provided there is no exchange of heat with the surrounding. So, according to the principle of calorimetry, when two bodies at different temperatures are placed in contact, heat lost by the hot body is always equal to the heat gained by the cold body, and there is a condition provided no exchange of heat with the surrounding. So, heat lost by the hot body is always equal to heat gained by the cold body, and this principle is called principle of calorimetry. Now we can do some numericals. A sphere of aluminium of 0.047 kilogram placed for sufficient time in a vessel containing boiling water so that the sphere is at 100 degrees Celsius. It is then immediately transferred to 0.14 kilogram copper calorimeter containing 0.25 kilogram of water at 20 degrees Celsius. The temperature of water rises and attains a steady temperature at 23 degrees Celsius. Calculate the specific heat capacity of aluminium. Given specific capacity of water 4186 joule per kilogram degree Celsius. Specific capacity of copper is 386 joule per kilogram degree Celsius. Here these are the values given. Mass of aluminium 0.047 kilogram. Its initial temperature is 100 because aluminium sphere is dipped in boiling water. So what is its temperature? 100 degrees Celsius. What is its final temperature when this aluminium sphere, after it is dipped in boiling water, it is immediately transferred to copper calorimeter containing water, and the final temperature is 23. So initially is 100, finally is 23 degrees Celsius. So what is the change in temperature? 100 minus 23, that is equal to 77 degrees Celsius. And we have to find out the specific capacity of aluminium. For copper, mass is given 0.14 kilogram. Initial temperature is, what is the initial temperature of copper calorimeter containing water? It is 20 degrees Celsius, isn't it? What is its final temperature? That is also 23. What is the change in temperature? 23 minus 20, that is 3 degrees Celsius. Specific capacity of copper is also known. And for water, what is its mass? 0.25 kilogram. What is the initial temperature of water? 20 degrees Celsius. What is the final temperature? That is also 23. And change in temperature is 3 degrees Celsius, and specific capacity of water is 4186 joule per kilogram degree Celsius. So these are the values given. And we know that heat lost by the hot body is equal to heat gain. Here heat lost by aluminium sphere is equal to heat gained by, what are the material gains? Heat gained by copper as well as water. Okay, when this quantity of heat is absorbed, copper gets heated, similarly water also gets heated. So heat gained by water plus heat gained by copper calorimeter. Okay children, so this is the main step. So heat, according to the principle of calorimetry, heat lost is equal to heat gain. Heat lost by aluminium sphere is equal to heat gained by water as well as copper calorimeter. We know the formula for quantity of heat, ms delta T, isn't it? Here ms delta T means mass of aluminium, specific capacity of aluminium, change in temperature of aluminium. Heat gained by water means mass of water, specific capacity of water into its change in temperature, plus mass of copper, specific capacity of copper into its change in temperature. Here we have to find out specific capacity of aluminium. Now we can substitute the values. It is equal to, after simplification, this answer is 3139.5 plus here after calculation you will get 162.12, and here it is 3.619 into specific capacity of aluminium. So after simplification you will get the specific capacity of aluminium as 912.3 joule per kilogram degree Celsius or Kelvin. This is the final answer. So specific capacity of aluminium is 912.3 joule per kilogram Kelvin. Okay, so this is the method of doing this numerical.